Hello, my dear students. Welcome to the class of 11th English Medium. The subject is Statistics, Chapter 7, Sampling Methods, brought to you by Vitan Sir. Previously, in this series of Chapter 7, we studied about the stratified random sampling. You can find that video at the top right corner of your screen. Let's start with systematic sampling. Now, this is the third and the last method of sampling according to our syllabus of 11th chapter number 7. That means this will be the last tutorial of this chapter number 7. This was a very short chapter, only kind of theory was there. So with this tutorial, I will end chapter number 7. When the complete list of population units are available and the units are arranged in some systematic order, that is, either they are arranged alphabetically, they are arranged geographically, or other things, this method is useful. That means when we have a complete list of population, by the way, in simple random and in stratified random also we require a complete list of population units. So technically in all the three methods included in our syllabus, we need the whole list of population units, else we can't do the sampling. But the specialty of this method is that they should be arranged in some systematic manner. That means even if the data is raw and it has not been arranged properly, we may need to arrange it in some system to use this systematic sampling method. The first sample unit is selected using a random sampling method, but all the remaining sample units are taken depending on the first sample itself. What we used to do in simple random and certified random was all the units were selected independently and separately and randomly. But in systematic sampling, only the first sample unit is selected randomly and all the remaining units depend on the selection of the first unit. That means this is not a random sampling. That's why random word has not been used in the name itself. You remember simple random sampling, stratified random sampling. This is just systematic sampling. So randomness is not there, units are not independent. All the units of the sample depend on the selection of the first unit of the sample. So such a sample selected is called a systematic sample, and the process of obtaining this is called systematic sampling. Let's see how we do this using some symbols. Okay, suppose we have total capital N units in a population. We will number the units from 1 to capital N. From this we have to select small n samples. So for example, we have 100 units and we have to select 10 samples, something like that. So capital N is the population, small n is the sample. That means we will divide capital N units into small n groups such that each group contains k units, where k is equal to capital N upon small n. So that means if I have 100 units and I have to select 5 samples, so 100 divided by 5 will be 20. So I will create 5 groups each containing 20 20 20 20 units. Okay, so I will be selecting one sample from each of these groups. That's what I want to say here, that out of 100 units I will create 5 groups of 20 each. So 100 will be capital N, 5 will be sample number small n, and 20 groups of 20 units each will be k. Here k is called the sample interval, small n is the sample size, and capital N is the population size. K, N and capital N must be integers. If they are not, we have to round it off or leave some units out of the population. Something must be done to make them integer. Now let's take an example to understand this method. Suppose we have alphabets from A to Y. Now I am not mistaken here, it is not A to Z, it is A to Y, and we have to select 5 alphabets from it systematically. So we have alphabets from A to Y, and we have to select 5 alphabets from it systematically. Now A to Y is capital N, that is 25. We have to select 5 alphabets, so small n is 5. So what will be the sample interval? So k is capital N upon small n, that is 25 upon 5, 5. So that means I have to divide my 25 alphabets into the group of 5 each. How I'm going to do this? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. Because total alphabets are 26, and if we divide 26 with 5, we don't get integers. So I just dropped Z. And now these are the 25 alphabets available with me. How do we do the systematic sampling? We have made 5 groups from 25 alphabets, and then what we are going to do here is we are going to select one alphabet randomly from the first group here. Okay, I have highlighted here. Let's see, we have A, B, C, D, E. We can take a lottery method, we can take a random number table method, but from out of these 5 alphabets we will select one. Let's assume it is C. That means because our sample interval is 5, each fifth alphabet we will select 1, 2, 3, 4, 5. So we will select H, then 1, 2, 3, 4, 5. We will select M, 1, 2, 3, 4, 5. We will select R, 1, 2, 3, 4, 5. We will select W, or just simply we can select all the letters which is below C. So the 5 alphabets which we were supposed to select are C, H, M, R, W. You see the system here that we just need to select one sample randomly from the first group, and then remaining samples are selected based on the selection of the very first sample. So when you divide your whole samples into the groups of Ks, that is sample intervals, you can naturally get your systematic sample in this manner. I will take one or two other illustrations to explain this properly to you guys. Do not worry, but this is a very simple method of getting a sample. Illustration 6, there are 40 flats in a multi-storied apartment. 5 flats are to be selected using systematic sampling from 40 flats for decoration in cultural program. Explain how the sampling will work. Okay, so now I have to explain how the sampling may work. First of all, here we have total 40 flats and 5 are to be selected. So the sampling interval will be K 40 upon 5 8. That means we will be dividing all of our flats into 8, 8, 8, 8, 8, 5 times. So from each 8 flats we will be selecting one sample, but what we are going to do is we are going to select first 1 to 8 flats and then select a sample from that. So the sampling interval is KH, so every 8th flat will be selected after selecting the first flat. So first flat will be selected from 1 to 8. Suppose from the first 1 to 8 flats, flat number 3 is selected randomly. I told you guys that from the first group we select randomly. So suppose that from the first 1 to 8 flats, flat number 3 is selected. So each 8th flat after 3, that is 3 plus 8, 11, then 19, then 27 and 35. Each 8th flat, so 3 plus 8, 11, 11 plus 8, 19, 19 plus 8, 27, 27 plus 8, 35. These 5 flats, flat numbers will be selected for the purpose of decoration. I hope you guys are getting how we are doing this. We just select first sample randomly, and all the remaining samples are selected based on the sampling interval K. So right now the first sample was 3, the sampling interval K is 8. So just add 8 till we get our number of samples. So that's how systematic sampling works. Let's take another example. An owner of a service station has a list of 1,000 car owners who have got their car repaired at his service station. He wishes to conduct a satisfaction survey of 50 car owners. Explain how a sample of 50 car owners can be selected using systematic sampling. Total are 1000. We have to select 50. So K will be 1000 upon 50, 20. So that means our sampling interval here is 20. So 20, 20, 20, 20, 20, 50 times makes them 1000 car owners. So each 20th, as the sampling interval is 20, each 20th car owner will be selected after we select the first car owner from the first 1 to 20 owners. Let's assume that from the first 1 to 20 owners, we are selecting randomly owner number 11. Randomly we are selecting owner number 11. So we will keep on adding up 20, 20, 20, 20, 20, 20 in this number till we reach somewhere near 1000. So 11, 31, 51, 71, 91 dot 971 and 991. So these 50 honors will be selected for the purpose of satisfaction survey. So this is how, my dear students, we conduct a systematic sampling. Illustration 8, select all possible samples of size 3 from a population of size 12. Now this is a very simple question, but there is a trick to it. Total are 12 and is 3, so the sampling interval is 4. The question here is all possible samples. Let's do something here. As the sampling interval is 4, every fourth unit will be selected after randomly selecting one unit from first 1 to 4 units. Let me distribute these 12 samples according to our 1 to 4, 5 to 8, 9 to 12 units. What we need to do here is, from the first group here, the first K value here, we have to randomly select a number and all the remaining bottom numbers will be selected together. But what we need to do here is we have to select all the possible samples. So we start with assuming that from 1 to 4 I have selected 1. Randomly I have selected 1. So if I am selecting 1, each fourth value 1, 2, 3, 4, 1, 2, 3, 4 will be the sample here. So if I select 1, then my samples, the first sample will be 1, 5 and 9. These are the probable samples. So either I get 1, 5, 9, or if I start with 2, the second option is from 1 to 4 I am selecting 2, then naturally these values will be the samples. So my second option for sample is 2, 6 and 10. Similarly, if by chance I select 3 from 1 to 4, then the remaining values will be the samples, that is 3, 7 and 11. So the third sample will be 3, 7, 11. And if I select 4 as my sample from 1 to 4, then the samples will be 4, 8, 12. So my dear students, this is how we select a systematic sampling. We divide our whole sample, whole population according to the K values, so that we can get n groups here. Okay, 1 group, 2 group, 3 group, because size 3, and in each group 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, because the K is 4. So from the first group we select a number randomly, and all the next values at till the bottom will be the part of the same sample. So this is the systematic sampling method of. Now let's conclude our tutorial with advantages and disadvantages of systematic sampling, starting with the advantages. It is easier to draw a sample and also easier to apply without mistakes. It's very easy. You just draw the first sample and then whoosh, you take all the bottom values, till all the values till the bottom. That's your sample done. Sample is evenly spread over the entire population, because we are dividing the whole population in the number of groups according to samples, and from each group we are taking a sample, so the sample is spread over the whole population. It requires less time and labor compared to simple and stratified sampling methods. So simple random sampling, stratified random sampling needs to be taken samples each and every time, but in systematic sampling you just need to select once and you get the whole group. The disadvantages: it works well only if complete list of population is available. I think this is the point common in simple random, stratified random and systematic sampling, that is we need the whole population. Arranging whole population in systematic order is time consuming. Not just time consuming, it's tedious. There may be errors. We may not have even uh, enough manpower to do that, and we may lose our purpose of sampling. It is not a complete random sampling, as I have told you guys earlier that only the first sample selected is random, but the remaining samples depend on the selection of first sample, so it is not completely random, and that's a big disadvantage. So my dear students, with this I end our tutorial here. This is the end of chapter number 7. I hope you liked it. Please give me a big thumbs up, subscribe to my channel if you are new, give your feedback in the below comment box, and I will see you next time with the next chapter. Thank you very much. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.